These last four look complicated. There's more going on, but if you factor, you're gonna see that the children got more for Christmas that are the same than what it looks like, okay? So for this first one, I can factor out an x, and I'm left with x minus 2. Now already you can see that I've got an x minus 2 right here. And then here's 3 over x. Okay, this child got both things for Christmas. This one wants an x, and this one wants an x minus 2. Okay, my denominators are the same. I can cancel those babies out. All right, now I've got 12 minus 3x, don't forget that's a negative, equals 3x minus 6. Oh, this is nice. Okay, I'm going to add 3x to both sides. I have 12 equals 6x minus 6. Now I'm going to add 6 to both sides. 18 equals 6x. Divide by 6. X equals 3. And if we plug that in, it does work. Okay. Next one. Okay, again, we're going to factor first. X minus 4 minus 30 over, this is going to be x minus 4, x minus 1 equals 3 over x minus 1. Again, we see that what the children got for Christmas, okay? So this one needs an x minus 1. This one needs an x minus 4. That middle child got it all. Can make that go away. Okay, I'm going to distribute this. So x squared plus 6x minus x minus 6 minus 30 equals 3x minus 12. Okay, let's combine like terms. So x squared plus 5x minus 36 equals 3x minus 12. This is a quadratic, so I need to move these two over and get it equal to 0. So minus 3x, add 12, x squared plus 2x minus 24 equals 0. When we factor this, we get x plus 6, x minus 4. So x equals negative 6 and 4. Now we look for extraneous solutions, and it's relatively obvious, right? If I plug 4 into here, I have 4 minus 4, that gives me 0. So I can't have 4, so 4 is extraneous in this case. All right, number 27. A little easier, I guess. And yet, not. Not as much stuff going on. Okay. So we need a common denominator. Well, there's only one denominator here, it's y. So I need to multiply, well, what I can do, excuse me, you know what, instead of doing it that way, what do we do when we have a denominator like this? I can just multiply both sides by y. And that gets rid of the denominator. Now I need to distribute this y, so I get y squared plus 4y equals 5. Let's get the y over to the other side since it's quadratic. when I factor this, I get y minus 1, y plus 5. So y equals 1 and negative 5. And when we plug those in, they both work. All right, finally, now this one, we do have some stuff to factor. So I've got x plus 5 over x times x plus 1 equals 1 over x times x plus 1. This time we have two spoiled brats. Okay, and one left out. And this one's really mad because they both got the same thing, and this one now needs an x. Okay. Now we can cross these all out. So this one's actually easier than it looks. Okay, so now we have x plus 5 equals 1. All right, a negative. When we distribute this negative, we're going to get minus x plus 6 times x. All right, so now I've got to distribute this x. So x plus 5 equals 1 minus x squared plus 6x. Now I've said it before, I don't like negative x squares, so I'm going to move all three of these over. So I add x squared to both sides. I'm going to subtract 6x, and I'm going to subtract 1. So I get x squared minus 5x plus 4 equals 0. And when I factor this, I get x minus 4, x minus 1, x equals 4 and 1. And just a quick look, I see they end up both working. Like I said, if you have an extraneous solution, chances are it's going to be a 0 in the denominator. So if you're taking the test and you don't have time to check for extraneous solutions, just check to make sure it doesn't make the denominator 0, and you'll be okay. All right, good luck on the test, and let me know if you have any questions.